Welcome. In this video, I will show you how to create phase envelope for a natural gas using Aspen Plus. It is a typical natural gas that methane has high mole fraction compared to other components. For a start simulation, let's move on to Aspen Plus. Click on New Simulation. In this section, we need to define all components of the natural gas. Okay, we have C1, C2, C3, C4, CO2, and N2. Okay, click on Next. In this section, we need to define the physical properties or the thermodynamic equation for our system. We have hydrodynamic system, so we select P. Robinson. The P. Robinson equation is suitable for predicting the thermodynamic properties of the natural gas. Okay, so click on Next, click on Run, and now let's move on to simulation. Okay, in this section, we select a material. Also, we select the mixer. Now we define the outlet, stream, and also we select the inlet stream into the mixer. Okay. The reason for selecting the mixer for this example, because the Aspen Plus do not run the model without a model. So you see that here we use a mixer as a model because the mixer do not change the physical properties of the inlet stream or the outlet stream because only we have one stream that insert to the mixer. Okay. So double click on this one. The temperature is 30 degrees C. The pressure is 80 bar. The mole flow of the natural gas flow is 100 kmol per hour. Okay. We change the composition to mole fraction. The mole fraction of C1 is 0.9, for C2 0.0, C3 0.02, C4 0.0. 1 for CO2 0.02 and also for N2 is 0.02. Okay, the sum of mole fraction is 1, so it's correct. Click on Next. For run the simulation, we click on OK. Okay. So the run has been complete. Now we move back to main flow sheet. Click on S1 stream and right click. Click on Analysis and select PT envelope. Okay. Here for the create the phase envelope, we click on Run Analysis. And here you see that the phase envelope of a natural gas. This phase envelope is very important for designing natural gas pipeline. This section we have liquid, this section is two-phase flow, and this section we have vapor. And above the critical vapor pressure, we have dense phase or supercritical condition. Okay, you see that how we can create a phase envelope for a natural gas. Also, you can use same step for creating phase envelope for another system. So it's very important you can find the region of the flow or the natural gas flow inside the system. Okay. For example, if you have temperature and pressure, you can easily find the region of the flow. Thank you for watching the video and good luck.